TalkShoe Live. This episode is being recorded and streamed live on TalkShoe.com. This episode is also being streamed to the following platforms: YouTube Live. You are joining the online studio. Your line is muted. You can unmute yourself by pressing *6 on your phone.
Now got streaming live on YouTube. I'll announce the recording. I'll announce the opening again. Power to the truth. This is Margo. This is Wednesday, August the 8th, 2018, and I'm doing a live ClimateCast update. And I'm live on TalkShoe right now, and I'm streaming live over to YouTube. So I'll probably get an audience, but this is mainly an update. There is a chat room over on YouTube as well as over here on TalkShoe. So thank you everyone who's joining me, and let's just get started. I have a lot to go over today for our update. It's been almost a week since I did my last ClimateCast update, and this is an announcement for our show tomorrow, Campfire Chats with Margo, and it's going to be here on TalkShoe under my Campfire Chats TalkShoe series here on TalkShoe, and that's going to be at 5 p.m. Pacific Time, 8 p.m. Eastern Time. And it's going to be an opportunity for people to call in. We're going to talk about all kinds of things. Also, Robin Westenra from New Zealand will be joining me on that show, and we're going to be talking about the rapid decline of the Arctic sea ice and some other things as well. So that's going to be a good show, and I want people to call in and share what's going on in your world, with the climate, and also how you're dealing with these changes that are going on with these abrupt climate change issues that are upon us. And what you have seeing on the screen here is the latest animation from the Navy website. It's the animated GIF for the ice thickness for 30 days, and it goes 3 weeks before today, and then it goes into a 7-day forecast period, so you can see kind of where we are with ice thickness in the Arctic, and you can see that it's really dwindling fast, and we've lost a lot. In the last month, we've lost a lot of sea ice, and we've got about another month or a little bit more in the melt season. Now, the Earth is starting to tilt back. The North Pole is starting to tilt back away from the sun, and so the days, the climate is supposedly getting a little bit cooler, but it's really warm up there at the North Pole. It's above freezing, and that's unusual for them. So we're going to go over all of this today. So let me pop over to YouTube real quick and see what kind of audience I have and what's going on. And it looks like we are live streaming. I'm showing a buffering. Hi, Robin Data. Thanks for joining me. I'm showing a buffering on my screen over on YouTube. I'm going to refresh that page. And that took care of it. And so it looks like our live stream is good. And Valhalla is in the chat room over on YouTube. Hi, Valhalla. It's great to see you. Thanks for joining me today. And Candace and Thomas, hi, how are you today? Thank you for joining me. Can everyone hear me okay? Can you just type into the chat room if I'm coming through okay, volume-wise? And then we'll get started in this update. And waiting to hear if I'm coming through. Okay, the audio's good. Thank you. Thank you over there on YouTube. So I'm going to start today with, I'm going to leave the animation up for a little bit here. And let's see. I want to start, I shut down Facebook. I'm going to open up Facebook again. You're not going to see it, but it's just, it's a statement Guy McPherson said. Can't remember if it was yesterday or today, but it is a comment that he made, and it was yesterday at 6:53 a.m. and he posted this on his Facebook page, and it's underneath a video that he put out that's called Edge of Extinction, Rate Matters, Nature Bats Last, where he talks about the rate of change matters, and the rate of the ice melt, and the rate of everything matters. But above that, he wrote 2 sentences. He says, "We're done. Really, we're done." And when I saw that, that pretty much says it all. You know how Guy is when he wants to make a really, really big statement, he uses as few words possible. So I think that speaks volumes. So thank you, Guy, for giving us that message, because I believe we are done. And you can see from around the world just what's been happening in this last week with the heat and everything else. Things are really getting out of control. So I'm going to stop this Navy GIF for a minute, and I have this really great program that I'm using called Honeyview, that when you download one of these animated GIFs, while it's playing, you can hit the plus or minus button over here on the left hand side, and it will stop the animation, and then you can go backwards or forwards in the animation to see, just to compare. So here we are on August the 8th, and this date down here where it says August the 7th, that's the date that it was analyzed. And then, but this is the date up here is the date that it's meant for. So it was analyzed yesterday, but it's meant for today, August the 8th. And you can see from this Navy GIF here, here we're looking down on the North Pole. Here's Greenland, here's Norway, Finland, Sweden, and then here's Russia and Siberia, here's Alaska, and then here's Canada over here. And you can see that the ice has retreated very much. This is Svalbard, here's Iceland down here. And the white area is down to 0 or near 0 ice. And then like the violet area is 0.5 meter. And then when it gets to the dark purple, that's about 1 meter of ice. This is the thickness. And then when you get to the aqua color, you're about at 2 meters to 2.25 meters. And so the old ice is right along here, and it's melting. And we've been watching this, and we've been seeing this, and this is the evidence of the ice going away right in front of our eyes. So I want to show everyone a slideshow here. Here we are. This is from Climate Reanalyzer today, and we're going to go through the websites as well. But I've downloaded the snow and ice cover image from Climate Reanalyzer from every day starting back on July the 7th when I discovered that big hole in the Arctic sea ice. And so what I like to do, the way I like to start out these updates is let's just do a slight review so that we can see where we came from, and then we can understand better the rate of melt and the rate of decline of the sea ice and the other factors involved as well. And so this is from today, and I'm going to blow it up so that we can get a better idea before we go to the NASA satellite view and everything, because we can really see the outlines and see the edges of the sea ice here. And here's Svalbard, here's Novaya Zemlya, and so it's retreated way in. Here's the North Pole, and it's well within the 80-degree northern latitude because that's more out here, and you'll see that on the NASA satellite view as well. And then it's well retreated from the Siberia coastline. Here's where the East Siberia ice shelf is, and it's retreating from the coastline here. And where it's darker, it's becoming much thinner. It's also less concentrated there too, and it means that it's melting faster there than in the areas where it's thicker and more concentrated. And we can see in this last week, we've had a collapse of the sea ice here in the Beaufort Sea. So, and then if we go back, here's the day before. And each day you can see where it was a little bit more and a little bit more. Sometimes it's better to see things in a reverse view rather than going forward, and then you can really see the difference. You can see the change. So here we were a week ago, last Wednesday, August the 1st, and you can see a marked difference, and this Beaufort Sea had some sea ice covering even then. So that's where we're at there. And I wanted to show something else very interesting. This image is from a NASA document called the U.S. Navy's Roadmap to the Arctic. And I'm going to blow this up so that we can see it a little bit better. Uh-oh, I'm still learning these programs. So what you're seeing here is not thickness, but sea ice extent. And these are the roadways or the routes that the transportation routes that they had planned for the Arctic once it melts enough to get everything going. And this has been in the works for decades. Now, what I found interesting about this map was this blue image and the outline is the minimum sea ice extent in 2012, and that was when the sea ice was at its most minimum extent. Now that's different from concentration and thickness. That just means that there was some kind of ice in on the sea, um, that at the most melted time. And this is the outline of 2012. And you can see that it went much further down. Um, you can see that it went much further down in along the south coast of Greenland. Then I'm having hard time manipulating this. Hang with me. But I want you to understand where we are in relationship to past year, like 2012. And then this is where the Navy projected the minimum sea ice to be in 2020. They expected it to come all the way out to Svalbard and about halfway down the east side of Greenland. That would be the minimum sea ice extent. And then in 2025, they expected it to come in more from Svalbard, but still further down on Greenland. And for 2030, this is what they're expecting for the minimum sea ice extent. So I want you to keep that in mind as we look through these pictures today. And we can come back to this picture as a reference point. And this is from the PDF that the Navy published in 2014. So this means they knew what was going on. Their climate scientists knew exactly what was going on, and they made plans. They've made plans, and they've gone forward with their plans no matter what any activists say, no matter what the climate scientists say, no matter what kind of damage they're doing to the environment. This is the reality. And it's not just the Navy, it's all of these Arctic countries that are in alliance together to develop this whole area of the Arctic. And they have big, big plans. So if you missed my video on that, it's a couple of videos back, and it's called As the Arctic Melts, the USA and other countries plan their further exploitation of the planet, or something like that. I can't remember the exact title. So there's that. So I'm going to pop over to YouTube real quick and see what's going on there, and see if there's anything I need to look at in the chat. Okay, I'm just trusting everyone is going to be on their good behavior in the chat. So far, I haven't seen any problems when I've gone live, and you know, the conversations are very interesting in the chat room over there. So I appreciate everyone being here with me today, and I've got 21 watching over on YouTube. So let's go forward with our update now. Now, I'm going to stop sharing that screen. And when you see that RE, the green RE, that means it's recording. That's the recorder icon. So I'm going to pin myself there so you don't have to see that. Okay, the next thing we're going to look at now is we're going to hop over to Climate Reanalyzer, and we're going to start our analysis for today. We're going to start with our temperatures. And I just want to pop over to YouTube and see how the screen is coming out. Uh-oh, I did something. Uh-oh. I hit the wrong button. I hope I didn't end the live stream. No, we're still live. Okay, I've got 23 watching. Okay, everything looks good over there. So I'm going to just go forward. And so we're starting with Climate Reanalyzer. Here's our 2-meter temperature for today around the world. And this is the average. Here's the maximum they're predicting for today and the minimum they're predicting, and that's usually at night. So looking at maximum temperatures around the world, we can see our graph over on the right. This measurement is in Celsius, and most of the Arctic is above zero, and the aqua color is at 0. And so you can see that there's just a little bit over on the west side that is at 0. And this is the air temperature, not the sea surface temperature. And then it goes up to higher areas as it goes to the darker green. And you can also see that the air temperature over the Atlantic Ocean, where it's entering the Arctic, is much higher today than we've seen as well. And this is another reason the Arctic ice is melting so fast. And so I'm just going to, since it's a global cast update, we'll just click around the world and you can see your part of the world and see what's going on. We can see high temperatures throughout different parts of the United States. We can see very high temperatures in Africa, extremely high temperatures in northern Africa, and then down here in the Congo, and over here in Saudi Arabia and across to India. And I know that Spain has been experiencing very high temperatures, and Norway, and it looks like parts of Norway are getting a little bit of a break today, but we're still seeing this global heat wave, and it's fueling wildfires and all kinds of stuff. And South America looks very bad, especially in the interior in Brazil. Here's Australia. Now Australia's not looking good, especially in the northern part, and it's had a drought all the way through Australia, and they're in the winter season. And here's the Antarctic. And I saw some article yesterday saying that on this West Antarctic Peninsula, the temperature, I can't remember what it was, but it was above freezing, and this is their winter time down there. So that's highly unusual. So let's go back up to this northern view, and now we'll look at the 2-meter temperature anomaly, and we can see that Greenland is much higher than it normally would be. And we can see our graph over here from white being in the normal range, and when it's blue, it's cooler than our normal temperatures. So we can see there's a little bit of a cool down up here in northern Canada and Alaska, but Greenland is hotter than normal, and this whole west coast of North America is hotter than normal, and all of Canada, it looks like, is hotter than normal. Then the east coast of the United States, and then the ocean area as well is hotter than normal. And then we can see Siberia, and this area is way above normal. And then um, over here with Norway and Europe and these areas as well. So we're going to start clicking through the globe. And here's Europe. This whole area is hotter than normal. And then Northern Africa, it looks like, and Southern Africa as well. And the whole eastern part of Africa looks not good. And then it spreads over into these other zones. Now, India is getting a break. It looks like parts of China is getting a break this week, but the northern part is not. And then these areas here. And you never know. It could be partly because of the jet stream, and the jet stream is definitely out of whack. And here's South America with areas that are higher than normal. And also, let's look at Australia first. The southern part, southwestern part is higher than normal. New Zealand is higher than normal. And then we've got this really strange system of temperature and air going on over the Antarctic, where you've got higher than normal air around it. And then we've got colder than normal air coming in. And then in the center of the continent, over the center of the continent, it's higher than normal in different areas. So it's really strange. I mean, I don't know what to make of this. I really don't. I know the ozone hole is growing, and we'll look at that today when we look on cams. We'll see that the ozone hole is the ozone is quite thin over the Antarctic, and it's actually growing in patches around the world. So we're not going to go through everything, but we will go through a lot of things today. That doesn't look right. Okay, I guess that is right. I just wasn't used to seeing that, right? So is it raining on that much of the globe? Is that right? The green is supposed to be rain. This is precipitation and clouds. The the I don't know if that's right or not. I don't think that's right. I think that's a mistake. Anyway, we're just going to move forward, and if it is a mistake, we caught it here today on our live climate cast with Margo. Leave it to me to find all the weird stuff. Okay, here's our precipitation over the Arctic, and we see it is raining, and a little bit of snow. The blue is snow. Blue is snow, and you can tell the level of the snow over here. It's mainly clouds over the Arctic, and then we have our different rain systems and different weather systems, and I can't specialize in everything. I'm really looking at sea ice these days, and and then I like to look at cams. So we can briefly go over some of these other things on Climate Reanalyzer that are interesting. And that's just so strange to see all that green. It's not raining over this whole area. That's got to be a mistake. That's got to be. That's all I know. So let's look at the jet stream. Here's a little tiny bit of a jet stream over the Arctic, and then it's coming down and around, and it looks like it's breaking up and looping And this is part of the disruption as a result of the heating up of the atmosphere with the jet stream going in crazy patterns. That's what all the weather guys will say and the climatologists will say. Now here's our jet stream in the southern hemisphere, and that could be causing those strange things that we're seeing in the Antarctic, I'm thinking. And look, it's going straight over straight over Australia, and it's very high in speed, very high. And now we're going to look at snow and sea ice cover. Now we're already down here on the Antarctic. It's still growing because they're in the middle of winter there, as you can see. And you can see patches of ice on the outside there. It's not very thick, and they don't ever expect the Antarctic sea ice to get very thick, but it does become concentrated, but it doesn't become very thick. And they do attain extent. And we already saw this view of the sea ice and snow cover for today, and we'll just look at it from this viewpoint now. And this is really interesting to see it from this viewpoint with Russia in the forefront and really see how much it's retreated from all of the Russian coast now. And so on. And now let's look at our sea surface temperatures. And this is going to tell us a lot about why the ice is melting where it is, because the sea surface temperature is above zero. And see, zero is the white color, and we're getting up into the purples and the blues over here in the Beaufort Sea and where it comes through the Bering Strait. And so we're getting up between like 5 and 10 degrees Celsius over there. So that's quite warm for the Arctic. And then you've got it warm over here, and you can see, I'm thinking like the water is coming in underneath the ice there and warming it up from the bottom. That's what climate scientists say as well. Now let's look at sea surface temperature anomalies. This is another important one to look at for us to understand the melting and where it's going on. We can see the red is very high, and we can see there are many areas in the Arctic Ocean where the temperature of the ocean is much higher than normal. And this is for many reasons, but also because of the warmer temperatures, all these lakes and rivers and the rivers that are flowing into the ocean are warmer. And so because they're warmer, they're flowing in and heating up the water as well. And also I found an article yesterday, I can't remember where it was, but now they're shutting down some nuclear reactors in Norway because the water's too warm to cool it. So, it's all over the place. Last time it was nuclear reactors in France. Now it's nuclear reactors in Norway. So there you have it. So we're going to leave Climate Reanalyzer. And now we're going to make the rounds looking at sea ice, and then we'll look at CAMS. And if we have time and I don't run out of energy, we're going to look at something else. So this is from the Arctic Sea Ice News and Analysis, National Snow and Ice Data Center. Now their data is a day behind, Now, what we're looking at here is the sea ice extent. Remember, that's different than concentration or thickness too. And we can see the extent. Here's the hole that goes from Siberia all the way across down, and there's some ice left over on the left here, and we can see how it's come in. And if you think back on that Navy map that I showed you, you can see we've already melted in so much within this line where they thought the extent was going to go even in 2020. So I think we're ahead of schedule. I think we're way ahead of schedule. So let me close this out. And now we're going, this is concentration, and they consider, okay, we're measuring concentration by how tightly packed it is together. That's my definition. And we can see the white is 100%, and then as it goes into the blues, it's less concentrated down to 15% and below. And the reason they don't measure below the 15% is that they consider 15% concentration or less as able to be navigated by ships, meaning that ships can sail through the ice. It's not to where it's blocking the ships to go through the ice, and it's considered open water. And so you can still have ice. You can still have ice, and it can be in chunks, and they can be close together, and you're going to see that on the NASA World View in just a second, that even though it shows concentration here, this is not solid ice. And so we're losing sea ice in thickness and in concentration and in extent, in all three. So we'll just go through all of the readings here on this site while we're here. Here's the graph, area of ocean with at least 15% sea ice. And they're a little bit behind on updating their graph. They're still in July here, but it's taking a nosedive in 2018, and you can see this dotted line was for 2012. That's kind of their measuring point, and so we're heading down. So here's the Antarctic, and they're in winter time, and their sea ice is still growing. And here's their concentration. It's not really concentrated a lot, but it is there, and that's what they count down there. And we see that it's struggling. It's still on the low side, and it's struggling with last year. It's a little bit higher than last year as far as extent, but again, we can see that can be deceptive. The extent can just be a little skim of ice, and they count it, and that can melt in a day. So now we're going to go to our Navy website, and here's our sea ice thickness from today. We've already seen that. And we can see, according to this chart, that most of the sea ice that we're seeing is in the violet to the purple range, or the dark blue. And the violet to purple is even less than half a meter up to like 3/4 of a meter. And then once it goes into the blue and the dark blue, we're looking at a meter to about a meter and a fourth. And then just a little bit is this old sea ice that's left. And also it's melting on this northern part of Greenland. And I saw a video, what was it, just yesterday or day before, about this ice lifting up. And this is unusual because normally the ice is solid over to the coastline of Greenland, but that's melting as well. And we can also look at the concentration here, and the concentration goes from red being 100% concentration all the way down through the oranges, and then the yellow is about 60, the 60 to 70 percent. And then we go into the yellow greens at 50, then the green at 40, the aqua at between 30 and 20, and then 10, and then you can see for yourself. Then it goes down to 0. And you can see the only area that's at 100%, that's the red, is down here in these little nooks and crannies. And so even over the North Pole, the concentration is not at 100%. It's not even at 90%. It's barely, I would say it's like around 80% if we're lucky. That's over the North Pole. And then it just thins out as you go out. And another thing I wanted to show you, now this is sea surface temperature. This goes right along with what we saw on Climate Reanalyzer. And I'm thinking this could even be more accurate. Remember, the Navy has an interest in what's going on in the Arctic. And so this is why I'm deferring to this Navy website and their measurements, because this is their latest data and their information that they're using. And this is what they're planning from. So you can see the sea surface temperatures really, really accelerating, especially around here off the coast of Siberia. And of course, that's where that East Siberia ice shelf is. And here coming into the Beaufort Sea, and from the Atlantic Ocean coming in. This whole area is warming up. The Hudson Bay is much warmer. There's no more sea ice in the Hudson Bay. And also, because of this ocean temperature is so much warmer, that's why we've already lost almost all the sea ice around Greenland. Another thing you can look at here that's interesting, that can help show us how the sea ice is breaking up. This is the ice speed and drift. And this is how the ice is moving on the surface of the ocean. And so you can see from the chart, the blue is less, and then, you go up to yellow is more, and then red, and then dark red. And then we can see the direction of the drift too. And so this can give us a clue as to how the ice might be breaking up, or where it's going to be breaking up in the coming days. Or if we see something unusual in one map or chart, we can come over here and say, oh, well, it's moving to the southwest at a really fast rate. And so we can be looking at maybe this area of the North Pole to see, well, maybe we're going to have a breaking up there soon. So there's that. Now we're going to look at the NASA worldview. Let me get a drink of my tea here. This data is from yesterday because their data is not in all from today yet, I don't think. Let me know. See, we have large blank areas. So all of the data comes in about a day from NASA. This is the satellite from above the North Pole is what we're seeing. And we're seeing here's Greenland. Here's our longitude and latitude markings. Here's the 80-degree north latitude circle. And the North Pole is right here. Here's Novaya Zemlya. There's a lot of cloud cover we're going to have to navigate through as we look at the sea ice today. So if we're unable to really determine the edge of it, we can always look back through other days as well to see if it was a little bit less less cloud cover, then we can determine more on the sea ice as well. And so we're just going to start zooming in, and we can see the edge of the sea ice here. Now let's look first of all at Greenland, since I talked about that. And you're going to see exactly what the climate scientists are talking about. Now that's as close in as I can get. And you can definitely see the open water. Here's the edge, where the edge of the land, okay? This line is the edge of the land, and you can see where the ice is and where it's lifting and breaking away. And so you can see that along a lot of the Greenland coast, the ice has already left. It's breaking up. This is cloud cover that we're looking through, that wavy stuff. And you can see, like in this inlet, even, you can see where the water is like, that's just water there. Then this is icy through this little channel. But a lot of these channels have already melted. I'm going to zoom out now a little bit. And we can even see the integrity of the ice from this view of how large these chunks are. And some of them are quite large, some of them are small. And we've got a scale down here. You can measure, like, here's 20 miles and 20 kilometers. Like that measurement is 20 miles. So some of these are large chunks, but they're still chunks. It's not solid. And also, when you move your cursor around, the longitude and latitude shows up down here. And if you want to change the view, like if you want to go to the South Pole, you can go to Antarctic. But you're not going to see anything because it's dark down there. It's winter time. But when we get at the end of our summer and into our fall, and the Antarctic gets into their spring, we can start looking at the Antarctic ice as well. So we can see this ice is really, really breaking up. I just find it fascinating to watch all of this. Now let's stay over on this east side for a little bit. Now here's the ice edge. We can make that out through the clouds. Here's Svalbard. And then the ice edge comes in here. Comes in here. It extends a little bit here and then comes in here. And this is all well within the 80-degree north latitude because here's that line. And the North Pole is 90 degrees. I thought it was 100, but then I started looking at this. It's like, oh, it's 90. And then it keeps coming around, and here's the ice edge distinctly. But it's pretty broken up there. When you zoom in, it's very broken up, as you can see. And then here's northern Siberia. And the ice is just in chunks here, but the main ice edge is here. Let's go back over to this east side and see what this ice is looking like here. Okay, we can see that it's definitely losing integrity here. That's as close as I can go in. We can see that it's like there are areas where it's not as thick as others and it's come apart. You can definitely see that, and these are holes in the ice. And then there's our 80-degree north latitude. So Robin, if you're watching, this is definitely losing integrity, getting closer to the North Pole. That's what we were talking about. Now you can see in detail here. Now see that and see the holes here. That's at 82.44 degrees north latitude. And you can see it even here as we get closer in. That's 83. And look at these holes here. And look at this area. That's at 80, almost at 85. That's 84.88. So Robin, you were right on about that. We're going to talk about some of this tomorrow in our Campfire Chat show. So, you know, people can come to these websites and look for themselves and see what's going on. And then here's the western edge. And there's quite a bit of cloud cover over here, but here's where it's collapsed this last week. This whole area here. And there's a little bit of sea ice over here. So I think that's enough on that for now. I'm going to pop over to the YouTube chat room and see what's going on over there before I go on to my next section. I've got 29 watching. Hi, Sandy. Hi, Sandy. Hi, Hopsutaki. Hi, Tree Hugger. All right, so okay, everyone behave yourselves because I'm not watching. So just be on your best behavior, okay? So let me hop back over. I don't have anyone over here at TalkShoe. I did have one person watching over here at TalkShoe when they left. That's okay. All right. Now, the next thing we're going to look at, hang on. Okay, I'm drinking my tea again. See how these climate casts can take so much time? I mean, there's just so much to look at. It's amazing how much there is to look at. Okay, let me get this next view set up here. We're going to look at cams next. Okay. And as you know, this is Copernicus Atmosphere Monitoring Service. Can everyone see that okay? I'm going to have to move the screen down so you can see it. Okay. I'm going to enable live chat for all the messages to be visible. Top chat holds potential spam, but this is so all your messages will be visible. I just enabled that. I see you're silly, Sandy. That's okay. I mean, that's a coping mechanism. I wish I could feel silly. I'm trying. Omega Man, you see things in the Arctic that you can't explain. Yeah, I hear you. There's so much going on that I can't explain. Just wait until we go through cams. You just wait and you see ozone. All right, here we go. We're heading into cams, so fasten your seatbelts. All right, what we're looking at is methane from the polar view, North Pole. And let's see how far back our data is going here. Okay, we got actually 4 days of data, which is a lot for us. For cams, it goes back from Saturday through Tuesday, which was yesterday, and then it goes into the forecast period. So let's just load up this movie. Let's see if it'll load up. It might take a little while since I'm live streaming. Maybe I need to close out some of my other browsers. Hang on, let me do that because I don't need them now. Yeah, I'm going to close some of these other things out. Well, it's still not loaded. All right, just be that way. Let's see if I can refresh the page and get something. Maybe we'll start with something else. Well, we'll just start it from here. While that's loading, let's go. Oh, here we go. That loaded up for us. And so we're going to go back to the beginning of this time period and run our movie starting from last Saturday. And if you've been watching my videos, you know pretty much what these colors mean in cams. This methane is measured in parts per billion, and this kind of medium green color is 1860 parts per billion. Then this next one is 1880, and then 1900. Then once it gets into the yellow, it's 1920, and then the kind of golden yellow is 1940, then 1960, then the orange is 1980, and then the red is 2000 parts per billion. And then it goes up from there. And it says on this chart, like this, almost this black color, it says it's 75,600. I don't know. I don't know if they just couldn't fit all their numbers on there or what. But that's what the chart says. And I'm just the citizen reporter here. So we can just watch this go through. And what's disturbing to me is how over here, over India and China and Asia and going up into Siberia, is just like one big black blob. And I don't see how anyone can say that these methane levels are nothing to be concerned about, like I saw in a recent video. I just don't understand that. I mean, Guy McPherson thinks that methane levels are something to be concerned about, and they are getting higher. They're definitely getting higher. We can see it very dark off the east coast of the United States and North America. We can see it very dark. It's covering up Florida. And it's a big black blob over parts of the United States, and then down here in Mexico, and down here in Southern California, and then Norway. And I mean, you can see for yourself. You can find your region of the world. We're going to hit all of them. You can find your region and you can see what kind of methane you've got that's heating up your atmosphere. Okay? So I'm going to pause that. Now we're going to go over to this flat view. This is the plots view. This defaults to total column, and even total column measurement is very high. This is the methane going readings all the way up through the atmosphere. It's up above, it's about 2,300 parts per billion over here in this dark area. So let's go to surface methane. And I'm gonna make my screen bigger. And now we get the whole world on one screen with my new computer. I don't have to move it around. So let's go back to the beginning of our time frame here. And we're going to run this movie. And this runs slower in this plots view for everybody. And actually, I'm seeing some methane coming up out of the Antarctic. I had seen this before, but I hadn't really mentioned it. It's not a extremely high level, but you can see a difference in the methane level down here in the Antarctic even. I don't know if that's just because it's drifting over from South America and reforming, Or, it could be from that warming down there and it's coming up from the sediments. I don't know. So New Zealand, here's your methane over here. South America has quite a bit. We can see Australia, you're not looking too bad with methane. Of course, you're still in your winter time and you don't have a lot of humid areas, but you do have fracking and oil drilling, and you do have some mining and stuff. And you do have industrial civilization that gives off methane as well. Now, what I'm really looking at a lot still is this methane coming up and coming up over into the Arctic Ocean and because this is gathering in the Arctic and it's making the atmosphere much warmer up there. Alaska has high methane. You can see that. Permafrost is melting really fast everywhere as well. Okay, so there's your methane. So now let's look at ozone next. Well, no, let's look at sulfur dioxide next. And then we'll understand why there are holes being eaten in the ozone layer once you see sulfur dioxide. Now let's see how far back our data goes on sulfur dioxide. They're usually current on sulfur dioxide. Yeah, it's through today. So we've got 5 days data from last Saturday through today, the 8th. So we'll have just a couple of days in the forecast period. So here's our flat view of sulfur dioxide. Now remember, sulfur dioxide is released from different kinds of things, mainly I see it a lot from geologic activity, mainly volcanic activity. It can be released from burning of emissions. It's and wildfires and things like that too. But we can see the Galapagos Islands are still, um, having volcanic activity. Vanuatu, down here in the Pacific Ocean, has still been erupting. Of course, we still have volcanic activity going on in Hawaii. We have volcanic activity going on in Mexico, and also on the west coast here on Peru. And then in Alaska, we've got active volcanic activity. And then we have the wildfires over here on the western part of the United States that are raising sulfur dioxide levels as well. And then we can also see over Saudi Arabia higher sulfur dioxide readings, and then over China and India here in Africa and so on and so forth. Now what I want to show you is how all the sulfur dioxide is mixing and gathering over the Antarctic too. And this is important because sulfur dioxide, when it goes into the atmosphere and starts breaking down into other things, it chews up the ozone layer. It literally chews it up. And we're going to see this in spades when we look at ozone. So let's look at ozone next. And we're going to start out with plots. We're also going to go back over here. And I want to show you ozone directly over the South Pole. And you can also see we're getting holes developing in the northern hemisphere as well. It just looks like just chunks. Chunks of the ozone are just going away. It's just patches. Patches are going away. And this is total column. And it goes back 5 days. So I'm going to switch the view to the South Pole. And it's measured in Dobson units. And the scale is down here at the bottom. And they say that 300 Dobson units is average, but that equals 3 millimeters of ozone through the atmosphere. It's not much. And so when you see like this aqua color, that's 225. This blue, this darker green, this aqua is 225. This darker green, like here, is 250. And then the chartreuse is like 275. But we have a lot of the aqua even around the equator. So we're losing the ozone layer, folks. And you're going to see this darker blue, that's 200 Dobson units. And you're going to see that pop up here over the west side of Antarctica. So let's load that movie. And I'm going to see what's going on in the chat room just because I love you guys so much. Do you like having the ClimateCast made live stream? Do you like that? I mean, I can do them live stream now that I know how. Type in the chat room if you like the live streams. I don't mind doing it live stream. Hi, Marcia. Hi, Redwater. Love you too. Oh, you're sweet. You love it, Environmental Coffee House, Sandy? Oh, thank you. Thank you, Hopsutaki. The chat's distracting. I know, Marcia. I know, but you know, people like to have the chat room. They like it, and you know, it's okay. I don't mind it. I don't mind it. You know, this is a place that people can come and share, and this is a community that we're building, and it's growing. So this is fun. Yeah, it is fun. Live stream is good. Well, now that I've got this new computer, I don't have any trouble live streaming. The old one just couldn't handle it. And it's easy to set it up, and I can live stream from TalkShoe, and then it's saved over there too. And it's really easy to do screen share. And so it's actually on 2 different platforms. Yeah, Marsha, you can turn the chat off if you don't want to watch it, but you know, it's okay. I find the chat interesting. But okay, I'm gonna get back to work here and show you guys ozone now. Okay, it's loading the movie. Okay, here we go. Pay attention, class, pay attention. Here we go. This is important for us to understand how screwed we are and how fast things are going to start falling apart. And it's going to start like immediately. And we don't have to lose every little bit of sea ice in the Arctic for everything to start going downhill. It's already going downhill. But we're in trouble. we're in big trouble, folks. You can see here, like this, the aqua color is filling up more of the Antarctic, and you can see this blue, which is the 20, which is the much lower reading on the Dobson units, appearing right over the Antarctic in two different places, and then it moves around and moves around. Granted, they're in wintertime, and the ozone is less in wintertime because it goes away in the cold. And it requires sunlight in order to make the ozone come back. The Earth makes its own good ozone. This is the good ozone that we're looking at. But, you know, with the sulfur dioxide, the way it is chewing up the ozone and spitting it out. So there's that view. And you can see this whole southern hemisphere is in like this 250 Dobson units. That's low, people. And 225, that's low. That's very low. Okay, I'm going to pause that. Now we're going to go back over here. And we're going to load this movie. And now we're going to see it from this view. And you can see your part of the world and see where it's thinning, but it's all the way around the equator. It's all thinning out. And then when you get into this chartreuse color, that's only 275. And that's almost the rest of the northern hemisphere and up into the Arctic. And see, it's even thinning out in the Arctic, and it shouldn't be thinning out up there. It's summertime. So I'm thinking it's because of all this sulfur dioxide and plus the nuclear power plants and crap like that. It's just chewing it up. And look, I hadn't seen this before. There was a big thinning over here in Canada. It just went by. We'll watch it go through in a second here. Here's a big thinning here in the Pacific. Look at that. Now, look, here it is by Alaska. See that? That's a lot thinner. That's 250 Dobson units. So with the ozone layer thinning like that, you're going to have more ultraviolet radiation coming through. And the ultraviolet rays kill the plankton in the ocean. And see, it's thinning over Greenland now too. That's not good. And it causes all that ice to melt faster. The glaciers will melt faster. Everything goes faster. Without the ozone, we can't live. Seriously. Ozone is very, very crucial to us. Now, let's look at bad ozone. That's the surface level ozone. And that shows up as a result of a few things. Sunlight interacting with pollutants in the atmosphere. It can also be from wildfires. It can also be a sign of geologic activity, a precursor of geologic activity. Now you're seeing high surface ozone layers over here on the west side of the United States. That's from the wildfires. And then it's spreading out. It's not all red, but even the green and up into the cream can be hard for people to breathe in. And there's also, last time I showed some surface level ozone. Here it is coming up out of the South Pole. And I didn't understand that. Now watch, see the green? You'll see green coming up in the South Pole. And sorry, I hit the microphone. There's no reason for that. You see that? The green, they're coming up in the South Pole. There's no industry down there as far as we know. And there's no sunlight. They're in the dark right now. It's winter time. And there's no sunlight. So why is there surface level ozone being created in the Antarctic? Unless there's some volcanoes going off underneath the ice and it's coming up, because there are 128 volcanoes under there. I don't know. I don't know. But it's just something very strange. Very strange. So there's your ozone. Now let's look at carbon dioxide, because I'm getting tired. And we'll finish this up. This has been going for a while. And we have our campfire chats tomorrow. I've got to get all rested up and in full swing for that. And I expect some of you to be calling in so that we can have a talk tomorrow night. This is total column carbon dioxide, and this is worldwide. So let's run this movie. I'm going to let that run. I'm going to pop back over to check on everybody. I'm going to pop back over to TalkShoe real quick. I'm all by myself over here on TalkShoe. And I'm going to pop over to YouTube. Okay, Hopsutaki, you said, can you still give us specifics at the end? Where's the chat stream? Wherever it is will take place. Oh, you mean tomorrow, Hopsutaki? I did an announcement video, and it's all in there. It's all in there, and all the links and everything are in the description. I did an announcement video a couple of days ago, so you can find it there. And it's talkshoe.com, and it's Campfire Chats with Margo. You just type in, browse shows if you want to, and then type in Margo, and then find the Campfire Chat series, and click on that, and you can join in. But you can watch. It's going to be live streaming over here onto YouTube. But if people want to call in tomorrow night, that call-in number is going to be for the United States 605-562-0444. And then the call ID is 144865, and then you hit the pound sign. And then that's calling in on the phone, and we can talk and have a conversation. And if you join the live studio over there, you can join on your computer if you're from a different part of the world, but you need a headset and a microphone, and you need Google Chrome for your browser. And they also have a lot of international call-in numbers. So, and I gave the link to all of that in the announcement. If you live in different countries, there's a call-in number for Germany and call-in number for Australia and different countries. So there's no excuse. People can call in tomorrow. Repeat, Valhalla, repeat. Repeat what? Repeat what I just said. The call-in number tomorrow night on Thursday is going to be 605-562-0444, and the call ID is 144865 and the pound key. Yep, there you go, Valhalla. I just told it. And that's going to be at 5 p.m. Pacific, 8 p.m. Eastern Time. Oh, thank you, Sandy. And then the call ID for tomorrow is 144865. And you have to punch that in once you get in on the phone. There you go. Everybody's got that. Okay. So you've been watching carbon dioxide now. How long have we been going? An hour and 26 minutes. This has been long. I have something else I want to show you. Is everybody up for it? This is kind of weird. I'm getting tired, but I really want to share this. Answer yes or no in the chat room if you want to hear the next part. Otherwise, I'll cover it tomorrow night with Robin. Yes. Okay. 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 You're twisting my arm. Everyone's twisting my arm. So I'm going to show this. Okay. We're stopping the global analysis. Stopping all of that. Stopping all of that. Stopping all of that. Now, this is very interesting, and it's real important to understand this. What I'm going to be showing you, I'm going to start out with one of a couple of posts from Robin's blog recently. And this one was from August the 5th, which was 3 days ago. And he's saying 1 month's worth of melting. And so he's showing, this is from the Navy website, starting from September the 1st and then to August the 4th, and shows the difference in how much we've melted. Now you see that this says GLB up here, right? This is very important. I want everyone to be paying attention. This is class time. So everyone pay attention, GLB, okay? Now you're going to see something else in a minute here. Now here's another blog post. This is from Tuesday, August the 7th. And this is as a result of a conversation that he and I had between some conflicting data that we saw from the Navy website that people were using. And I admit in my Arctic sea ice update, I went into this old part of the Navy website and I found the thickness of the sea ice from 2012. You remember that? Well, that was in a different part of the website. And that part of the website, they're not updating that part of the website anymore. And that was a different modeling system. But it took some time going back and forth and looking at a bunch of figures and different things and everything. And Robin and I were going, you know, this data, even though it was the same day, it looks so much different. What's the difference? What's the difference? And I said, well, the only thing is it has to be a different modeling system. And so he messaged Sam Carana, since he knows Sam and I don't. So he messaged Sam and asked him, were there different modeling systems from the Navy and this and that, which one should we be looking at for current data? And here's Sam Carana's message back to Robin. He says, there is a discrepancy between two different models, see below, making it more difficult to compare previous years with current data. This is a reply to an inquiry from Sam Carana. Here's what Sam Carana says. Exactly, Robin. Good that you figured this out. I've tried to explain it many times to some other people who keep mixing up images made with different models, which causes all kinds of problems. Anyway, the newer model is better, so the measurements for 2018 are good, but they cannot be easily compared with some of the older measurements, such as for 2012. Cheers, Sam Carana. Okay, you got all that? So that's real important. And what I've noticed is a lot of people are using this old data and then they are trying to compare it with the new data and it doesn't compute. And so I'm going to take you through this blog post of Robin's, and then I'm going to show you a couple of things and how you can recognize the difference between the old data and the new data, so that if you see someone's video and they are trying to show you information from the Navy website and you don't know if it's old data or new data, there's going to be a way that you can tell, okay? Because I figured it out. Okay, and so this is Robin's blog post, The Disappearance of Arctic Ice 2012 to 2018. Here's a graph that plots the decline of sea ice volume as it heads down to zero. And this is from Sam Carana. And this started in, what year was this? 1975 down to 2025. And he shows it going away completely around 2023. But we can see, like, here's where we are on the graph right now. So that's about at 4,000 cubic kilometers. So that's where we're at. Anyway, I just look at the graph going down and it doesn't look good. Anyway, the following demonstrate how the ice has become thinner over the years since 2012, which saw the record low ice extent. Okay, remember, extent is different from thickness. From ice that was 2 to 4 meters thick, it has reduced to 0.5 to 1.5 meters, with a tiny slither of old multi-year ice off to the north of Canada. All the data is from the beginning of August, close to today's date. Okay, here's 2012. And this is also the view that I got from the Navy website in my sea ice update. You see that? And you see how thick it was and how far. Now the extent was low, and we're probably going to get less extent than that. Of course, that was August, around the same time. So we're almost at the same extent, but their thickness was more according to this chart. According to this chart, their thickness was up to 5 meters in this dark area right above Canada. All right. Now, you see it says ARC. It doesn't say GLB, does it? It says ARC, and that's the difference. That's how you can tell it's from the old modeling system. Here's 2013, and here's the date up here. Remember, we saw that. This is 2013. This is from August the 5th, 2013. It looks similar to 2012. Here's 2014 ARC. August the 5th, 2014. Okay. Here's ARC 2015. Okay. We saw quite a bit of decline there in the thickness, though, starting in 2015. Now look at this. And Robin says, note, beginning in 2016, the U.S. Navy has changed its system from ARC to GLB. I'm unsure what this means, but I posted both. I'll show you what it means in a minute. 2016 ARC, the thickness from August the 4th. So this was 2 years ago. And it's much thinner. You can see it's much thinner, right? And then, well, okay, this is ARC. Now look at GLB from the same date, August the 6th. And it doesn't compute because according to this ARC map, it shows like the edge of the sea ice being like just not very much purple, but it's mainly like this dark blue and going into the green. So it showed a lot thicker, whereas from the same date or within 2 days of the same date, 2016, on the GLB model, which is the newer modeling system, it looks very similar to today, doesn't it? See all that violet? That's very thin sea ice. So that's a huge difference. And so what some people are doing, not knowing, or they might know, is they're drawing from the wrong database and they can't compare. You can't compare current year's data to other year's data from the different modeling system. You can't. You have to use the same modeling system for it to be an accurate comparison. Now here's August 6th from 2017 in the GLB, which is the current modeling system. And you see there's a lot of thin sea ice. And here's the ARC version. And see, it's much thicker. Okay, this is real important to understand. And here's 2018. And in 2018, this is the only modeling system that we have. Okay, now, Robin continues, this climate change denial website says it is the authorities cooking the data. Quote, the U.S. Navy recently made most of the Arctic sea ice disappear using the tried and true climate science method of simply changing the data. And Robin says it certainly makes things look very different. Certainly the ice is disappearing. The NASA satellite photos confirm that. So see, this is from 2 different modeling systems. So I know we're going long, but I want to show you this. This is how disinformation comes about. And so I click on that link, and this goes to the Deplorable Climate Science blog. And this is a climate deniers website. And I wouldn't be surprised if this is a government website. I wouldn't be surprised one bit, because see, they're comparing from the ARC to the GLB. They're comparing 2 different modeling systems and saying that the Navy made it go away. No, the Navy did not make it go away. The ARC is an old modeling system that they're not using anymore. The GLB is the global forecast system that they're using. Let's go there. That's just one picture. It doesn't even go to the website. It just goes to one picture. So, you understand all that? I also saw a video recently that somebody who's supposed to be some scientist put out, and he'd gotten his data from someone and gotten some of these Navy charts from the Navy websites, and he was doing a similar comparison from the last few years, and it was a mixture of the ARC data and the GLB data, and I'm like, someone needs to educate the public about this. So I'm going to show you that real quick. I'm going to educate you because this is important, and we're just going to do it right now, and we're going to see the difference. Now, here is the website from the Navy where it says this is before you go into the new system is here. The Global Ocean Forecast System 3.0. It says, so this is the old system up here, and it says they're using all these different things: real time, 1.5 degree Arctic cap, HICOM, ice, ENCODA, nowcast forecast system, or ACNFS, with NavGIM atmospheric forcing. So that's what the old system was. Okay. And it says, as of September 30th, 2017, ACNFS will be replaced by the Global Ocean Forecast System, or GOFS 3.1. Daily Arctic and Antarctic ice products are available from the GOFS 3.1 webpage. The ACNFS webpage will remain in service for historical purposes, but will not be updated with real-time ice forecast products. Okay, so I'm going to copy this. We're going to have 2 of these up here in the web browser. And in this web browser, I'm going to go to the new system. And we have a choice of Antarctica, Arctic Ocean, and Beaufort Sea. Okay, that's how you know you're going into the new system. It also says GLB up here. Now, if you want to look at the old system, just for historical data, this is from 2017. They haven't updated it. And you have a choice of Arctic or Beaufort. Okay, you go to Arctic, and it says movies and snapshots of this. And then it says snapshot archive. And when you click on this, it's 2017. That's the last data that they put in here, 2017. And then here's the archive. And this is in the old system. You can go back. Okay, it needs to calm down. You can go back to 2012 from 2017 in this old system but it ends in October of 2017. That data ends. But they started their new system. There was an overlap period, okay? There was an overlap period. And in the new system, here's what it looks like. And we can see, now let's see the difference here. The difference in the title is the HICOM/CICE. And this one says Global HICOM. Okay, so that's the difference. So you want Global HICOM for the current system. And so when you go here, that's today, all right? And then when you go to Snapshot Archive right here, they had an overlap with the newer system, and then the old system was back over here. But this is the new system. Right here from this page, you can go back to 2016 and 2017 in the new system. And this one started we have all of 2016, okay? But we can also access 2015 and 2014 when they had this overlap period. Sometimes these links don't work for me. Sometimes they do. Okay, so right now, this is in the newer system with the global, the GLB, that's what the picture will show up as. It's all of 2015, and here's 2014 as well. And it goes started from June of 2014 through December, okay? So that's how what all of this means, and that's how you can navigate this and understand what you're looking at. And just for an example, let's go to July and let's look at July 6th and see it's GLB. And we're looking at ice speed and drift, GLB. So that's the new system. Okay, so that's how you can tell. Does everyone understand that? This is important. So when you're comparing, this is why it's so hard to compare data, because you have all these different modeling systems. Does anyone have any questions about those modeling systems? Right, Valhalla. The two systems were overlapping, and that's prudent for them to have an overlap period to make sure that everything is working and that they can work out the bugs before they phase out the other system. Yeah, we can pick up all of this tomorrow, but I wanted to give you an overview of all of that so that you understand when Robin comes on tomorrow, we're going to be talking about this stuff. Okay, we're going to be talking about it. So thank you for joining me today. I so appreciate everyone being here with me and hanging with me. And I'm not just talking to the air. I know I've got 31 people watching over here on YouTube. A lot of people are leaving great comments, and thank you for being so loving and kind to one another. And I'll see you tomorrow night for campfire chats. So I love all of you. God bless you. Thank you, Osama, says you're a champ, Margo. Thank you. God bless everyone. People, time is short. It's time to get your spiritual houses in order. I love all of you, and I'll talk to you tomorrow night. Take care. God bless. And I'll just type a sign out message. Thank you. Everyone, take care. Be strong. Time is short. And Guy said it. This is it. We're at the end. All right. Talk to you tomorrow. Take care. Good night.